Jai Ho students, welcome to SKCBSE's DG Vidya class session. Dear students, in previous class we have discussed about how to prove root 2 is irrational number, root 3 is irrational number, root 5 is irrational number. Clear? So we have discussed the proof of these irrational numbers, and today we have to discuss about the decimal expansion of rational numbers. Okay, in class 9 you already studied that the rational numbers have decimal expansion either terminating or non-terminating repeating decimal expansion. Yeah, so that we have discussed with the class 9 standard. So what we have discussed, the decimal expansion of rational numbers is either terminating or non-terminating repeating. Clear? So these concepts we have discussed in the class 9th standard. And in 10th standard, without performing actual division, by seeing the question, by seeing the rational number, easily we can say whether it is either terminating or non-terminating repeating. Easily we can confirm, easily we can say that whether it is terminating decimal expansion or non-terminating decimal expansion, that too without performing actual division method. In class 9 standard we have did division, complete division. Then later on we came to know that whether it is terminating or non-terminating repeating decimal expansion. But here we have to go for one step ahead. That is, without performing actual division, we can say that whether the given rational number is either terminating or non-terminating repeating. Clear? Okay. So to perform this one, we have 3 theorems. What are those 3 theorems? So let us see one by one. So that is the first theorem. The theorem 1 is states that, what it states, what is the statement of this theorem? So let x be one of the rational number. X is what type of number? Rational number. We have to think only about rational numbers. Keep irrational numbers aside. Okay? We are only concentrating on rational numbers. We are concentrating on rational numbers and their decimal expansion. Clear? Okay. So first theorem, what it states? What is the exact statement of theorem 1? Let x be a rational number. X is what type of number? Rational number, and it terminates. Rational number whose decimal expansion is terminates. Means after some steps we obtain remainder 0. Clear? So that's why it is called as terminates. Let x be a rational number whose decimal expansion terminates. On what condition it terminates? Let us see. Then x can be expressed as, x can be expressed in the form of p by q, where p and q are co-prime numbers. Co-prime numbers, and the prime factorization of q is of the form 2 to the power n into 5 to the power m, where m and n are non-negative integers. It means they are whole numbers. Clear? So this is the first theorem what states about the decimal expansion of rational numbers. In general, I can say that the theorem 1 can be shortly written as, let x be a rational number whose decimal expansion is terminates, then x can be expressed in the form of p by q, where p and q are co-primes. Then the prime factorization of q is of the form 2 to the power n into 5 to the power m, where m and n are non-negative integers. It means they are whole numbers. Clear? This is the first statement. Clear? Okay. So this statement is only in the form of sentence. But what exactly it tells? Suppose x is what type of number? Rational number. Rational number means it can be written in the form of p by q. That is 7 upon 4. 0. That is 7 by 40. So what we have done? What we have chosen? X is one of the rational number. X is one of the rational number and whose decimal expansion is terminates. We have to think that the decimal expansion of this rational number is terminating. Yeah. Okay. So this can be expressed as p by q form, where p and q are co-prime. P and q are co-prime numbers. They don't have any common factor other than 1. So 7 and 40 are co-prime numbers. Now, and the prime factorization of q, here p is 7, q is 40. What is the prime factorization of q? That is 40. We have to check. The prime factorization of 40 we have to check. If this is in the form of 2 to the power n into 5 to the power m, then this rational number has decimal expansion that is terminates. Clear? So shall we check? Is 40, is q in the form of 2 to the power n and 5 to the power m? Shall we check? Check now. That is 40. Prime factorization of 40. How to find prime factorization of 40? That is, it is divisible by 2. 2 20s are. 2 10s are. 2 5s are. Then 5 1s are. Yeah. So this can be written. That is 40 can be written as 2 to the power 1, 2, 3. 2 to the power 3 into 5 to the power 1. 5 to the power 1. Yeah. So here we have seen that the prime factorization of q is of the form 2 to the power n into 5 to the power m. Then easily we can say, without performing actual division, easily we can say that this rational number has terminating decimal expansion. Clear? Understood this? So here x we have taken as one of the rational number whose decimal expansion is terminates. Then it can be written as, which can be, x can be written in the form of p by q, where p and q are co-prime numbers and the prime factorization of q is of the form 2 to the power n into 5 to the power m. That is, m and n are non-negative integers. Clear? This is the first theorem what it states with example. So once again I will explain this theorem, that is, let x be a rational number, x is one of the rational number, and its decimal expansion is terminates. Suppose they give in exam, what type of question? X is one of the rational number, one rational number they give, and its decimal expansion is terminating. Then what will be the prime factorization of q? That is denominator q. Then they ask, at that time we have to write this one. The prime factorization of q is of the form 2 to the power n into 5 to the power m. So like this we need to write. In general, theorem 1 states that x is one of the rational number whose decimal expansion is terminating. Then x can be expressed as a p by q form, and p and q are the co-prime numbers, and again what they have given, and the prime factorization of q is of the form 2 to the power n into 5 to the power m, where n and m are non-negative integers. Yeah? So this is the theorem 1. In the next class we discuss about theorem 2 and theorem 3. So till then, take care. Jai Hind.